Oh. Okay, so the last class we looked at was IJ vectors, wasn't it? Yeah. So what we're going to look at now is how useful IJK vectors are for calculation of magnitude and direction. So let's start off now with the formula. Yes? You got your notebooks?
No.
Are you making notes? All right. So if you think about in 2 dimensions, so there's the I and there's the J, and here's our vector, let's say like this. So this is xi plus yj, or another more convenient way to write it would be like this. xy, like that. So let me call this vector R as an example.
I'm sorry, I cheat the sheets of the questions.
Nah, because I've just been using the book, the chapter. It's quite good. That's what I used last year as well, I think. Yeah, if you want to practice, just use the book on Moodle. Did you download it? Yeah. This symbol here means when you're talking about vectors, the magnitude, or in other words, the length. So if you actually look at this here, it's just a right angled triangle when you think about it. How big would the horizontal be? It'll be x units. And the vertical would be y units. So you have this formula. If you want the magnitude of the vector xy, it would just be square root x squared plus y squared. And if it was in 3 dimensions, it is not really different at all. X, Y, Z, it'd be square root x squared plus y squared plus z squared. Okay, got that so far? Okay, so that's the magnitude. The next thing to look at now is the direction. So here, I'll call this angle here phi, or theta, or whatever. So how could we find this angle? Well, again, if you think about it, it's just a right angle triangle. So we can use the formula phi equals tan inverse y over x. That's all. You know, remember this from semester 1. However, now this is where it can get difficult to imagine because you need to think about it in 3 dimensions. So if you were just in 2 dimensions, you have your vector, you have your x, and you have your y, okay? And then you've got your angle using tan inverse, that's fine. But if it's in 3 dimensions, that's like your 2 dimension, except it comes out of the page, so to speak. So there's actually another angle here. So there's 2 angles. This one here is in the xy, and then there's another angle in the z, the sort of one that comes out of the plane. And that angle there, again, it's a similar formula. It's tan inverse z over the magnitude. Like that. Now, if you think about this formula for the moment, suppose that my vector was just in 2 dimensions. So what would the z be? If it's only in 2 dimensions, what would the z be? Yeah, so what number would the z be? 0. And what tan inverse of 0 is 0. Which makes sense, because if it's only on the table, it has no angle off the table. Okay? So, it's not really too important, it's not really important at all, that you know where this formula comes from. I mean, we could do the proof, but in fact, I think for every single exam I've seen, if they ever ask you for an angle, it'll always be this angle. They've never asked you for this angle. They've always asked you for this angle. Yes, Faisal? Question?
What exactly is that?
It's the extra third dimension.
Yeah, so it's the length of the...
Yeah, well, it depends which way you want to draw your axis around. So if I'm using my table here, for example, this is the x, this is the y, then the z would have to be this one up here. Yeah? They've never asked for this. Okay? They've always asked for this one here. So I don't even think that they would ever ask this. But just in case, that's the formula there. And you can see it's very similar to the first one I gave you. So that's how you calculate direction.
Or both, right? Both formulas are to calculate direction.
Yeah. The first one is in the xy, like that. And then the next one is the off the xy, so to speak. Okay, so now let's look at some example questions then. You have those formulas? I think the magnitude formula is in the formula book, I think. I'll have to check. Well, the formula book's on Moodle, so you could check. I don't think the angle ones here are in the formula book. Okay, so just to get you started, I'd like everybody to give me the magnitude and direction for this vector here. So take out your calculators and give me the magnitude and direction of this vector. This is the magnitude. Okay. What did you say?
261.
Yep. And then the angle now. So if I have a look here, it's 189 and 180. Okay. So it'll be square root 189 squared plus 180 squared. And what did you say that was, Hassan? 261. And then the angle would be tan inverse 180 over 189, which is 45, 44.
43.64.
Okay, so to the nearest degree, it'd be 44 degrees. So if you were to draw this vector, its length would be 261 units, and the angle it makes would be 44 degrees. That's what it would look like.
189 is R and 180 is Z.
189 is X, 180 is Y. There's no Z in the first example.
Isn't this formula for the magnitude, isn't it similar to the one in trigonometry?
Yep, there's a lot of relationship between this and for trigonometry. Yeah, so it actually is basically Pythagoras' theorem, and the other one is just your sine cos tan. Yeah. Okay, so let's have a look at another example now. So in this next one, I give you the magnitude and I give you the angle. It's a 193 and 61. So now I tell you, here's the vector 193, and the angle here is 61 degrees. And I want the I and I want the J. Now, if you think about it, this is really just semester 1, because if I call that x and I call that y, you can say sine 61, what would that equal? What fraction? Y over 193. So y would equal 193 sine 61. And likewise, x would equal 193 cos 61. So therefore, this factor here, I'll call it or. Can you type them in, please? What's this one? 193 cos 61.
93.
Okay.
94.
94. 169. Or if you want, you can write it with the I and the J. Okay, I'll give you a moment. Okay. So, just for practice, I'd like everybody please to try 2b by themselves now. So 2b. Do you know which one to do for me? So I want you to try 2b. Okay, so does anybody have the x and the y? What did you get, Curdy?
52.
For the 32i, yeah? 60j. Matches up? Yep. Yep, good, okay. Now, yes? You have it the other way around? Hassan, what did you get for the I? 60i. What did you get for the I?
No, the I is 32.
Goodness sake. What's the magnitude here? 68. And the angle? 28. Alright. So I know a quick way to do this. It's always going to be 68 cos 28 here.
Sorry, the direction is supposed to be... The word direction should be in the arrow.
Yeah, hang on. Is the problem that we misread it? Hang on. The magnitude is 68 and the direction is 28 degrees. So we can see that the 28 is the angle. Was that the problem? Did you have it like this? Yeah? So 68 cos 28, what's that? 60, alright. And then 68 sine 28, what's that? 32, right. And that will be the I and that is the J part. So Why, this is semester 1 trigonometry, folks. xy cos 28 equals x over 68. Therefore, x is 68 cos 28. Yeah? No, I'm moving on before I have a heart attack or something.
Calculators on road.
So that's wrong. This is right. Yes? Good. X is I, Y is J. Yes. Oh yes, don't mix that up now. Yes. All right. Moving on. Okay, so let's have an example here. Okay, so here, vector A, as an example, is 3i plus 4j, and vector B, as an example, is 5i and 12j. Okay, I would like to know, just as a small example, what is the magnitude of vector A here? Well, what would it be? Square root 9 plus 16, square root 25, so, right. And you can see what the B will be? 13, yeah. But I don't want that. What I actually want is the length from A to B. So does anybody got any ideas how I could go about doing that? And before you say anything, it's not a right angle triangle, so you can't use Pythagoras here. Well, it's usually not anyways, yeah? No. Well, I mean you could, but that's not the quickest way to do it. Nope. Oh, definitely not. Well, depends what you mean by add, though. You see, if you think about it, we have A and we have B. So what I'm really asking you for, if you think about it as a vector, is I want the magnitude of the vector A to B. There's A, there's B, so that vector is A to B. All agreed? Yes? So I want the magnitude of that. Now we know A, we know B, so how could we work out AB? If only there was some rule. B minus A. So I'll just B minus A, so 2 and 8, isn't it? That's B minus A. So in fact, this vector here is the vector 2, 8. So you can see my graph isn't so good because if it was 2, 8, it should be pointing to the right instead of the left, but that's okay. So that would be square root 64 plus 4, so square root 68 then. Yep.
Where did you get the 2?
That is, I use the formula B minus A. So 5 minus 3, 2. And 12 minus 4, 8. See that there?
Well, yeah, but why we don't say that 13 minus 5?
Ah! Because these are lengths. So for example, if I said here, like if I gave you this right angle triangle here and I said this is 3 and this is 4, you know that this is not 3 plus 4. That when you talk about lengths and triangles, they don't add together like this. So in fact, unfortunately, we can't say we can't say this will be 5 plus 13 or 13 minus 5 or anything like that. Yes? Yes.
Why did you do B minus A?
Because that's the formula for AB. AB is B minus A. You forgot this?
No, I know this, but like,
Yeah?
don't you want it already from A to B?
Yeah.
So why do you change it and do B minus A?
But But B minus A is AB. They're not different, they're the same. No.
I get it.
Do you? I don't know.
Because I see the modulus thingy,
Yes.
then the answer is going to
Yes. No, I don't know.
Okay, just.
Can we, yeah, go ahead. All right. I would like you to try this one at the bottom here. So I give you an A and a B, and I want the length from A to B. You can't see, you can't see. Here, let me zoom in as well, actually.
Could you please go back for a second?
The notes. Okay, so I'll just leave that there for a second, and then you can try one.
Sure.
You got it? Yeah? Okay. Yes? Question? No? So I'd like everybody to try number 3 for me, please.
It's like that.
Yep. In fact, it doesn't change anything really, because it's all exactly like what I did, except you have 3 components instead of 2 to subtract. Okay, so how many people have an answer now? Do you have one? So what did you get, Hassan?
175 plus 88J.
Ah, yeah, but give me the magnitude. See, I want the length, not the vector. Give me the magnitude of that. Joseph, what did you get?
135.
135. Miranda? Did you do what Hassan did and stopped when you got the vector?
Yeah.
Yes, I want the magnitude. I want the length. Yeah. Yeah, so 135 about.
Just solve.
Yes, I can. Just call out the vectors to me now in a minute, okay? So, all right. So the first one, what was it? A.
It's I,
Yeah.
J,
1. Yeah.
1.
Okay. And then the B.
It's 32,
Yeah.
89,
Yeah.
minus 84.
Okay.
94, sorry.
94. All right. Sorry. What, minus 94. What was the middle part? The J.
89.
89. Okay. So that's the A and the B. So if you think about it, there's O, there's A, there's B. And we know this vector, that's A. We know this vector, that's B. And I'd like to find this vector, AB. You have a formula. AB is B minus A, which would be 27, 88, and minus 99. And the length of this, the magnitude of it, would be square root 27 squared plus 88 squared plus 99 squared. The minus is not important because it will be squared. So what is that, Hassan? 135.18. So 135 then. What's wrong, Faisal? Don't look happy. All right. Yeah? Well, do you need me to leave that there for a minute for you to write it down? So that little question I did there, that'd be a nice, kind of straightforward section A question on vectors. They give you an A, they give you a B, and ask you for the length between A and B. Or they give you an A and they ask you for the magnitude of A or something like this. Okay. Let's have a look what's next. Yeah. Right, so next now. Did you write that down? Yeah, okay. Unit vectors, what's next? Now, just to prevent any confusion, this is the last thing to do for today in vectors, but we are not done vectors. Yes? Okay. So what is meant by a unit vector? No, I'm just a definition. So unit vector is any vector that has a unit. Sure, why not? A unit vector is any vector that has a length of 1. So for example, this vector 3, 4 is not a unit vector. However, this vector here, 0.6 and 0.8, that is a unit vector. Just out of curiosity, how many people will put an N here? For English use. How many people would write, I feel like this is something that's new, no, I hope, how many people would write not A, but rather AN? Yeah, no, I would like to know, would anybody write this? Not really? All right, good. Okay. But what rule do you use for when you use this or not? Oh, very good. Okay. Good. Is this something you knew already or something that you were taught here? Oh, all right. So, I don't know, are your English teachers teaching you much or? I just thought that might have been something new, but the fact that you all knew it, I'm quite impressed with. Anyways, English aside now. So this one is a unit vector because its length is 1. So just so you know, there's a different symbol we use when it's a unit vector. So if it's like this, not a unit vector, we normally put a little arrow on the top. But when it actually is a unit vector, what is normal, now not everywhere it does it, but what's normal is rather than an arrow, you put this hat symbol on top. It's actually called hat, yeah. Yeah. How is it not? But how is it not? Yeah?
I'm sorry, is that R under the
This thing here? Yeah. Focus, please. Hey. Good. Right. Now, what we're going to look at is how you can make a unit vector from a non-unit vector. So, for example, I give you this vector here, and it's the vector 5i and 12j. Now, of course, that's not a unit vector, so I'll write it like this. So what I would like to do is, how can I make it a unit vector? In other words, can I find a vector which points in the same direction but is a unit vector? It has length 1. So does anybody have any ideas how I could find that smaller vector from the bigger vector? Well, let me just give you a little hint for a moment. So if I said this vector here is x, and I say its length is 2 units long. So if I want to make a vector that's 1 unit long, I would just have to make a half x. You see, if this was 2 units long, then the unit vector version, you'd have to multiply it by a half. You'd have to shrink it down to length 1. So, you can imagine now, as a rule, if you want to make a unit vector, you just take the original vector and then divide it by its length. So in this case here, what's the length of this vector? It'd be 13. Square root 169. Okay? So, in fact, the unit vector then would be 5 over 13 and then 12 over 13 would be the unit vector. So you can check that does have length of 1. And it will point in the same direction because it's a multiple of the original. So that's also another point worth saying. It is the length of this vector. Square root 25 plus 144. Square root 169, so 13. That's an important point worth making note of here. Vector or, and if you multiply vector or by any number, they'll have the same direction. Well, with one exception.
Is that lambda?
Yes, it's lambda. I said if you multiply a vector by a number, it will have the same direction. It's just made bigger or smaller. Although there is one exception to that. Can anybody tell me? Yeah, because minus actually flips it around. So as long as your lambda is positive, all you're doing is changing the length of the vector. Rescaling it is the word. It's worth making note of that, so can you write that down, please? Ah, see, thinking way ahead of you. I said greater than 0, but not equal to 0.
Is this recorded?
Mm-hmm. Okay, did you write that down? Yep. Okay, so there you go. I'd like you to take this vector here, 8a, and make it into a unit vector now. Yeah. Okay, so what did you get as the magnitude actually first, the length of the original? 95, exactly, yeah. So that means then the I part would be 5 over 95, so what's that, 1 over 19? Did you leave it as a fraction? Yeah. So what's the J part then is 90 over 95, so what's that, 18 over 19? And the last one is 30 over 95, which is 6 over 19. Yeah? You're so eager to wrap this lesson up.
No, I'm asking it. That's the final.
As simple as that. Yeah, simple. Like all maths. Okay. To notes? Yeah. Okay. So unit vectors, the reason that they're so important is because they provide convenient bases. And what I mean by that is, what are the two vectors that are really convenient to use in the 2 dimensions? What 2 vectors? We use I and we use J. And part of the reason that they're so convenient is, number 1, they're perpendicular, and number 2, they're both unit vectors. They both have length of 1. So if you just did a quick check here, the length of I would equal the length of 1, 0, which would equal just 1. And likewise for J. But I mean, you knew that already. What I want to point out is, if you think back maybe a week or so ago, if you're talking about 2 dimensions, how many vectors do you need in 2 dimensions to describe any vector? 2. With one condition put on those 2. And what is the one condition? They're not parallel. That one is not a multiple of the other. So normally we use I and J. But what we'll see next time is, if I give you 2 vectors, like let's call this one here X and let's call this one here Y, and I say use these as a base now, the first thing you would have to do is convert them into unit vectors. So that would be X there with a little hat, and then that one there would be Y with a little hat. So if you had AI plus BJ, you could rewrite that as, let's say, lambda x's plus mu y hats there. So like for example, you can see that this vector here, this vector here would be roughly 1x plus 1y. So I'm just saying sometimes it's convenient to change what we say, change the base. And it's not actually too difficult, believe it or not, to find this lambda and this mu. Once you have this and once you have this, finding the lambda and mu isn't actually too difficult. And it will use something, a type of multiplication. I think somebody was asking me last week, can you multiply vectors together? Who was asking me that? Or maybe they're not here. Somebody was asking me last week, could you multiply vectors together? And that's what we'll do in the next lesson, which is called the dot product or the scalar product. Does that word mean anything to anybody? Yeah? What's a scalar? So I'll finish it there because I just need a couple of minutes to talk to the physics students about their lab results there. I can give you feedback. So that's Curdy, Joseph, Sayun. That's it? No Brendan, no Abinu, no... Oh, Ali's in the other class.